Hello everyone. Today we're going to do our live coding for LeetCode 4032. Longest subarray with at most k distinct prime factors. So we're giving an input of an array nums, and we want to return the maximum length of the subarray that has k at most k distinct prime factors. So to solve this problem, first we need to let's say max equal to little 10 max. We first need to find out at the method to find out the prime factors of the number, right? So for each number, we can essence of goal is for each number we need to find out the factor prime factor set list. Import Java utils stuff. So basically for every number we get to the prime set, the prime factor set. So right now we want to get a set of integer get prime factors int num. So prime factor set equals new hash set. So in order to do that, we can iterate start from tool, and the maximum we can get is less than equal to num. The product of itself is less than equal to num of I. So what we can do is if num is divisible by I, then we can add it into our set. However, let's see a set number is 2 divided by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5 equals to 8 multiplies 8 multiplies 9 multiplies y equals to 40 multiplies 9 equals to 360. In this case, for every factor we need to do division, continue doing division, continue doing the division until we have removed all the factors, all occurrence of this factor, let's say 2. So if it is divisible by 2, then we should keep divided by 2 until 2 is not there. And in this case, and then we come to 3. If we divide by 3, we get all the 3s out from the numbers. And if we get 5, we get them. In this case, I think what happened is I must the prime factor. Of course, bool can would not be divisible by num when you choose to 4. So any number of I that is not a prime factor, not a prime number, during these iterations, it cannot be divisible by num and anymore. Because if I is not a prime number, so it means it had a factor, prime factor before. And that is smaller than itself. When we come to 4, we come to a number that is smaller than 4. For example, 2, and that 2 had already been fully removed from from num. So this is done possible. So we can say this should be safe. The prime factor I would always be a prime vector. I must be a prime factor. So like 4 einen num prime num. Okay. Yeah. I think in the end, once we do all these, there's also a possibility that now is greater than 1, then we should also add it. Because in the end, when this is num is left and we have reached all these numbers, and then we should add it none. That now has been keep dividing, and then to be smaller. So the last number that is not a 1 is it's also a factor, and it's also prime factor, because there is no number that is smaller than the number at this moment that is divisible by it. All the factors have been extracted, so there's no factor void. So we can do this. So I said now what we can do is we have find out for each number, for int number nums, what we can do is we can get set num get prime vectors and add this list. So now for every number, we have already find out the prime factors. For every number in this list, we already find out the prime factor. Now let's find out what is the longest subarray with at most k distinct factor. So the ideal is here is to use a slide window. So we have our left and right. So what we do is we should add 1 num into the state, and then check first num left and right. Enter 1 number which is right to a state. So into the state. While state is invalid, remove left and move left ++. So we need to maintain a sliding window, and if every time do 1 step of this window into the window, and when this state is invalid, we should move left until it becomes valid. So either it is already valid, then we can do step 3, calculate length, compare with max length. So in this case, what we're doing is So state is valid. Calculate and compare with max length. So in this case, what we're doing is we add a number into the window. Here with the stated value, we go to step 3 and calculate the length, and we query in the max. Then we try to increase our right pointer to the window again, and then do it here. If the state is embedded, we can do more left and try to reduce the window. Reduce window by the movement, and then don't let cusp press. Then this window is reduced, so this it would end up with a state was valid. So in the worst case, left and right are equal, and left is also removed, so that the window it becomes 0, and then it will be less than k prime factors always. So that's a general template of slider window. Then let's see what is the state. How to define a state and check if it's valid. So I think here we have for every number we have a set of prime factors, and then within this window we can maintain our map, factorial, blind factorial, count. And then as we increase the window, we can update. We have a new number and a new set of the prime factors. We can update this map. As we decrease the window, we can also remove those prime factors and update the count argument element. And then hey will with this map.size is what we try to compare. So let's write the code. For int right equal to 0, right less than num stop length plus right. So it was a getter state. Map integer backpole map count mad equal to mad. We already have this max kill, and we also start with last equal to little. So now we try to get to the find fractals of the count map. Factorial set equals to dot get void, and then we try to add it to the map. Ball can blind factorial in the prime factor count map. For the it reads through this point vector in set, and in call equals to get all default zero, and then we put and factorial count password. So we have we check we get the prime factors of the right number, and then for each of the number we try to update the count prime factor count map. So right now we have added the that one is add right into the state, which is a map, and then we check while the state is invalid, it's invalid, then we need to move left. We need to move the left. So we also need to get the prime factor from the left. And then what we do is for each of the number, we try to iterate it. And then we try to get the count equal to, we try to get the number prime factor. So here is the thing, if count equal to 1, we just remove it from the map because it doesn't exist anymore. Pairs, we should do count minus 1. So in this case, we have initially left is in the window, and then now we have a removed left, so we should move left. So in this case, if it's bigger than no, we should remove it from the state and also move to the next left. And then here, after we remove it, we check whether state is valid. If a state is valid, the loop will break. So in this case, if the first left, after removing the first type, it becomes valid, then the window is close the window, right. Window is close the window. Then so at this moment, the right is in the window, left is also in the window, and at this moment it already become valid. If it initially valid, then like left is also in the window, and 0 is also in the window, right is in the window. So that's correct. So then we can say len is equal to right minus left plus 1, max equals to max, x max man. So let's go through this again. We have get a prime factor of the every number and put it into a set for each number, and then put it into a list. And here on, like we every step, we need to add one step for right, and then we check if it is valid or not, and then like we calculate these two lengths. So this will make sure we do not miss any right, any window and at the right, and also for the left, we also move every step and check if it is valid. And in this case, we won't miss any numbers that is starting and left. And once left is valid, we will the next iteration will move the right, and it will also check whether the window is valid. And if it is valid, then we will get the updated length, which is one more than the previous length, and then we just like keep updating. So and then this is get a prime factor function. We try to the trick here is try to divide num by every factor, every prime factor, and as much as possible. So in this case, all the 2 will be extracted out, all the 3 will be extracted out, and then once come to 4, it won't be divisible by 4, because 2 is already fully removed. In this case, the num is fully divisible by all the prime factors. And then the last one is also a factor of initial num, and it must be also a prime factor because our non-prime factor is already fully extracted. So yeah, all those smaller ones have fully extracted, so we won't end up any 4 left. So that's why we get the prime factor. So yeah, that's all for this code implementation. Hope this is helpful. If you like this video, please do a like. If you have questions, welcome comment. If you want to subscribe to this channel, welcome subscribe. I will be providing more problems and solutions in the future. Thank you.